Hey, how's it going, everybody? This is Cesar Vasquez here at GFCTI, Gulf Coast Technical Institute, and this right here is one of our trainers. Specifically speaking, a flow trainer that consists of the 4 basic variables of how to measure flow. On the principles, this right here is what we call a Coriolis flow transmitter. This right here is a differential pressure transmitter in a flow application. And then we come over here. On this side, we have the magnetic flow transmitter, and then the actual vortex flow transmitter with their own individual control valves. Some valves are fell open, some valves are fell closed. They have an SIS on it where these have the solenoids, where 3-way solenoid valves, where if an upset does occur, then it doesn't matter if the system has air, these valves are going to cause this actual system to fail regardless of the situation. So once again, these right here are their own individual positioners that we teach our students pretty much how to mount them, how to configure them, and how to actually troubleshoot them in the real world scenario. So if you come right here, this is our control panel. You have 2 PLCs. This PLC right here, which is the 1100 series, is a controller PLC, while this one over here, the 8020 micrologic controller, is the SIS. So as you can see right here, you're going to be dealing with the 4 basic signals of instrumentation, which are your digital inputs for DI, digital outputs for DOs, analog inputs, AIs, and analog outputs, which are AOs. And they're all pretty much tagged up. It's minor tagging that I still need to do, but for the most part, this is what a standard control panel will look like. If you look over here, there's your 120 distribution and your 24 volts distribution with their respectable terminations on the type of signal you're dealing with. So we come over here. This is one of the screens that we're going to be dealing with. Here's one of the HMIs, and here we have the VFD. We're going to end up putting this screen right here and attaching it here, waiting for some minor parts on that part. But this right here is the controller, and if you look right here, pretty much lets you know everything that's going on. So right now we are in alarm, so we come right here saying that the air supply alarm system is inactive. So if you look right here, it's pretty much failing. So if I go ahead and start the system, give it a couple of seconds to see it start up, and here we go. So normally speaking, if I were to fail it again, you actually do have an annunciator. But if I go ahead and activate the system once again, I'm able to acknowledge it and it goes away. So this gives you the ability. It has 3 switches. One switch is measuring the air falling, so falling, failing, and these 2 right here are ascending. So this one right here is a pressure switch high, and this right here is a pressure switch high. This one right here is the one that really activates the solenoids, deactivates the valves themselves. And then we have this actuator valve that I still have to wire up. This is going to end up letting me know there's actually air present. So I have 2 pressure switches that are measuring flow, while one is measuring the air supply. This is going to give me feedback if I actually have air present, because this one requires about 50 psi, while the rest require about 40. So once this one stops getting the pressure that it needs, it's going to send me a feedback signal that's saying that the pressure is deactivating, which is going to send me another alarm that I'm going to go ahead and activate, which is this one down here. I have it right here. It's just standalone for right now, but it's air supply actuator valve condition. So once I wire it up to give me feedback, I'll be able to add an additional alarm so that we're able to troubleshoot the system and the students can figure out what the issues are. And yeah, that's the flow system. Yes, sir. What's up?